Right. We are going to start today by checking the answers to your all right, we're going to check your exit ticket answers. So if you want to find that from yesterday. If there are any questions you have on it.
Yeah, check. So much.
All right, so number one, you can travel 26 miles per gallon. X is the number of gallons, so just 26x is your equation. B, so when you're talking about domain and range of just that equation, the answer will be all real numbers for both domain and range. But when we talk about in context of real life situations, it's no longer all real numbers. So the domain, which represents your x's, which are gallons in the tank, you only have a certain range of numbers of gallons that can be in your tank, 0 to 14. Could you be at 0? Yes, if your tank is empty. Could you be at 14? Yes, if your tank is full. That's why there's brackets on either side. And then you can actually use those numbers to figure out the mileage then, the range. If you have 0 gallons in your tank, you're going to go 0 miles. And if you have 14 gallons in your tank, you're going to go 14 times 26, 364 is the miles there. So that's where those domains and ranges come from, okay? Number 2, you have to set the denominator equal to 0. Now, when I did it, I divided through the negative, flipped all the signs because it makes it easier to factor. Remember, if you get stuck on the factor, you always have a quadratic formula in your back pocket. Oh, hello. Gotcha. So if you get stuck on the factor, you can use that. That's how it's factored. My 2 domain restrictions then are 2 and -1. And then we talked about yesterday how to write that. You jump over -1 and 2 respectively when you write that interval notation. Everything should be a parentheses on that one. Okay. Any questions on 1 or 2? Okay, number 3, I would call this an advanced level domain type question. It's very difficult to solve for the domain when you have squareds and you have an inequality. So what I would kind of steer you towards is just to kind of think about what kind of x values would give you negative numbers underneath here. If I plugged in 4, I'd be okay, because that would give me a 0. But anything bigger than 4 will give me a negative number. And that goes the same for anything smaller than -4, like a -5 squared I plugged in would give me a negative. So anything bigger than 4 would be a restriction, and anything smaller than -4 would be a restriction. Those are numbers I can't plug in, which leaves me only -4 to 4 can I plug in there and get a positive number underneath my radical. And this is exactly the opposite. If I plug in anything between -4 and 4, it gives me a negative underneath. So it's either got to be smaller than -4 or bigger than positive. And then at the bottom, there's the domain. You can have this written in 2 different groups. If you guys have, let's jump in there. -4 to 6 with the bracket, and then 6 with a parentheses to infinity. That is also correct. I would not take off points if you had that on a test or a quiz. But remember, if you are jumping over a number and one of them's a bracket, it means you don't actually have to jump over that number. You're allowed to equal that number. So you can kind of squish those pieces of interval notation together. Okay? Any questions on recap exit ticket from yesterday? Yes?
What was number 1?
Number 1. There you go. All right, so you can put that away when you're done checking it. Let's give you our notes for today. So today we start 2-5. those notes up for us here. Where did I put those? Here we go. All right. Okay, so we're going to start by, just like the last couple days, defining a couple things, and then we'll do just a bunch of examples to practice. All right, so today we are talking about different properties of functions, and a lot of these you're going to be able to see with a graph. That's actually how we're going to start with these today. So have you guys ever heard of the terms increasing, decreasing, or constant in terms of a function? You maybe even talked about it with like slope. If you have a positive slope, the function is increasing. If you have a negative slope, it's decreasing. If you have a zero slope, it's constant. So that might be where you heard those words before. Everything's not a line though. So in general, we say that part of a function that's increasing is where the graph is going up. And we always, always, always read a graph like we read a book from left to right. Okay. The part of the graph that is decreasing is the part that is going down from left to right. And the part of the graph that is constant is horizontal, zero slope, from left to right. Okay. When you list increasing, decreasing, and constant, you will use only x values and parentheses. You will use only x values in parentheses, so when we do the examples at the bottom of the page, you'll kind of see what that looks like. Okay. Extrema is a fancy way of saying your min or max points, highest points, lowest points. It doesn't have to be the highest point on the graph. It could just be like the top of a hill or the bottom of a valley. Okay, so where the graph, we like to say a lot of times, turns around, that would be a minimum or a maximum. If it's turning from increasing to decreasing, or it's turning from decreasing to increasing, bottom of a valley, top of a hill. Along with mins and maxes, any horizontal lines or horizontal segments are also considered minimum and maximum values. Okay. Finally, and we'll add a little bit more to this later, even and odd functions. These are going to be fancy terms for things that we've kind of already talked about in the last chapter. Remember we talked about symmetry to the x-axis, y-axis, origin in the last chapter? If a graph has symmetry to the y-axis, it is even. If a graph has symmetry to the origin, it's odd. If it has symmetry to the x-axis, it's actually not a function. It doesn't pass the vertical line test, so we don't even worry about that guy. These are the only two types of symmetry that can be functions that would pass the vertical line test. So even, symmetric to the y-axis, odd, symmetric to the origin, and then it could be neither if you have no symmetry. All right, so the first thing that we're going to do is we're going to look at these graphs at the bottom, and we're just going to name all this stuff. So there's not a whole lot of work associated with these. We just kind of look at the graph and locate the things that we're trying to find. All right, so first thing I'm going to find in letter A is any intervals where we are increasing, decreasing, or constant. And these are going to be separate: increasing, decreasing, and constant. Okay. All right, let's start with where the graph is increasing. That's where it's going up from left to right. So usually your minimum and maximum values are going to be helpful, okay? But do you guys see that that red segment there is where it's going up from left to right? Okay, the only thing that we're going to use when we list increasing, decreasing, and constant is x values. So what x value does it start increasing at? -1. And where does it stop increasing at? 1. And it's going to look like that interval notation that we saw yesterday. -1 to 1, always parentheses. Even if there's a point there, these are always parentheses. Okay? Decreasing. There are two places on this graph where it's decreasing. Here on the left side, and then here on the right side. Now, it starts as far to the left as you can go, and then increases all or decreases all the way to what x value? -1. So we say it decreases from negative infinity, as far to the left as I can go, all the way to -1. And then it decreases again from 1 all the way to what? Infinity. Positive infinity because it's going to the right forever. Okay, we're just thinking left to right. Are there any places where this graph is constant? No. Yes. You do not need to put the U on these. If you can, it's not wrong, but you don't have to. Okay? All right, second thing we want to find is any relative extreme values, which is a fancy way of saying minimums and maximums. Usually we just list the whole point. So I have a minimum at that bottom of the valley there, which is, what is that point? -1, -2 is a min. And then I also have a max at 1, 2. It is also possible that you can just say the y value. Min and max refer to a height. So you might see minimum at -2, maximum at +2. That would be sufficient as well. We usually just list the whole point here though. Okay. Third thing I want to name is if this graph is even, odd, or neither. Okay, so even means I can reflect it over the y-axis. This is my mirror line and it looks the same. Does it look the same on both sides of the y-axis? No, it does not. Okay, odd is symmetry to the origin, and we talked about with symmetry to the origin before. That was the same as a rotation of 180 degrees. So you guys can do this with your paper right now. Just turn it upside down. Does that graph look the same if you turn it upside down? Yes. So we have symmetry to the origin. So the answer to the question is this is an odd function. Any questions on any of those terms? All right. Let's practice the next one together, then the third I'll let you try on your own in a little bit. Okay. Places where this graph is increasing, going up from left to right. Can somebody give me one interval where this graph is increasing? 0 to 1. Perfect. Okay, that's that little guy there. Is there anywhere else where this graph is increasing? Yep, and that guy right there. 2 to positive infinity. Perfect. All right, anywhere where this graph is decreasing? Perfect. Negative infinity to 0. This guy right there. All right, anywhere where this graph is constant? 1 to 2. Great. Any questions? Okay, next. Do I have any minimum values? 0, 0 is a minimum value. Are there any other minimum values? No. If there was a solid point at 2, 2, that would be a minimum. But it's an open circle, meaning there is no point there. Okay, so no minimum. Are there any maximum points? Tops of valleys. 3, 2 is not a maximum because there's actually more points to the right there that go a little bit higher. Think about it as like a place where my graph turns around. So is infinity a point or a number? Remember we talked about that yesterday, but that's like a common thing that people think. Like, yeah, for sure. Like the highest we can go is infinity or the lowest we can go is negative infinity. But do we ever reach infinity or negative infinity? So we don't call it a min or a max.
Could it be the little line?
So it's not actually considered a, well, kind of, sort of. So if I just said strictly a maximum, the answer would be none here. If I say both min and max, that horizontal line segment is considered both. Any place you have a horizontal line segment, it is considered both a minimum and a maximum. How we write that is we would say from x equals 2, no, x equals 1 to x equals 2 at y equals 3. Y equals 3 is the equation of that little horizontal line, but the horizontal line only goes from 1 to 2. Okay? So both a min and a max is any horizontal line segment. Third, is there symmetry here? X-axis, y-axis. Well, x-axis not worried about. Y-axis or origin. Can't flip it over the y-axis, look the same. Flip the paper upside down, doesn't look the same. So this would just be a none. Okay. All right. See if you guys can do this one. Okay. You're going to have to use the pies on the bottom there. Okay, so I have increasing from negative pi to 0 in red there, and then again from pi to 2 pi. Decreasing from negative 2 pi to negative 1 pi, and 0 to pi. No constant intervals here. You have two minimums at the bottom, negative pi negative 1 and pi negative 1. You have a maximum just in the middle there on the y-axis. The other two are open circles, so they're not considered maximums at 0, 1. And then this guy is even because it is symmetric to the y-axis. Okay. Any questions on any of these properties? Yep.
Do we have to like put all the like places it could be, like how you have like
Yes.
negative pi to 0?
Absolutely. So if there's more than one, you got to list them all. You need your graphing calculator for the next problem if you want to get that out. Okay. So we are going to use our graphing calculator to sketch these graphs and then calculate any relative min or maximum values. So first thing you need to do in your calculator, y equals, let's just type these equations in. So we'll do the one on the left together first. 3x to the 4th plus 2x to the 3rd minus 7x squared. Ooh, that's not a squared. Here we go. Plus 3x minus 1. Make sure your plot is off. Shouldn't be highlighted. And then graph. If you're in a weird window, you might have to hit zoom 6 to see this picture. Get a little bigger. There we go. All right. Everybody get the picture okay? Any questions so far? Okay, great. All right, next thing we're going to do is calculate min and maximum values. So you should be able to look at this picture and say, okay, I know there's going to be a minimum down here, and it looks like there's a maximum there, and there's a minimum there. So there's 3 of them that I want to calculate, which means we're going to do this procedure 3 times. All right, so I'm going to calculate the one that's off screen down below there that I can't see just yet. Okay, so I'm going to hit second calculate. And I want it, it's a minimum, it's at the bottom. So I'm going to choose number 3. And then here's the things the calculator tells you. It's going to ask you 3 questions at the bottom. It says left bound, then right bound, and then enter. Your calculator wants to know, where is this minimum at? It's asking you what's on the left and what's on the right. So you guys should be able to look at this and say, it kind of looks like it's at -1. You guys see that it kind of looks like that minimum's happening where x is -1? So all you have to do is list a number to the left of -1. So I'm going to list -2. Doesn't have to be -2, but keep it like relatively close. Maybe like -3 would work too. Okay, so I'm going to hit -2 and enter. And you're going to see it's going to create like a little bar on one side. We're creating like little boundaries, like a fence on either side of my minimum. Okay, then it says right bound. I want to choose a number to the right of my minimum. Again, I think my minimum is about at -1. So I'm going to choose 0 and then enter. And now at the top of your screen, you'll see 2 little arrows that should be pointing at your minimum. Last thing it says is guess. It's asking, do you want me to guess? And the answer is yes. So hit enter. And then at the bottom of the screen, it should tell you a minimum value. And mine is saying my x is -1.43. My y is about -12.9. Did everybody get that okay? We're going to do it 2 more times. Any questions on that process? Okay, so what was that? Negative, I'm just going to do 1 decimal place. Negative 1.4 and negative 12.9. It says thousandth at the top. I'm not going to mess with that right now. Okay, let's try now to do the maximum. I had that minimum down there. Let's get that maximum right there. Now, this one's a little tricky. It kind of looks like the maximum is close to 0, but it's kind of hard to tell. So I'm going to zoom in a little bit. I'm just going to hit zoom in, number 2, and then it'll automatically zoom in around your origin if you just hit enter. Okay, so that'll give you a better picture of like what's happened in the middle of that graph. I just hit zoom in, enter. All right, let's calculate the maximum, the top of that hill. So we're going to hit same process again. Second, calculate. This time we want a maximum, so it's number 4. Now, let's say you don't know what x values to type in, what's on the left and the right. Here's another way to do it. You just take that little blinking cursor, move it to the left of the hill, hit enter, move it to the right of the hill and hit enter. Sometimes that doesn't work when our graph gets really steep. You kind of like lose the cursor, but this one wouldn't be too bad. You can actually see mine's already on the left side of that hill. So I can just hit enter. If yours isn't, just move it over a little bit. Okay, then when it says right bound, just go to the right of the hill. As long as you're on the right side of that top part, you're good. Hit enter. And again, you should see 2 arrows pointing towards that maximum now. Last thing we're going to do is guess. Enter. And it should say about 0.26 and negative 0.64. Everybody get it okay? Okay, so what did I say? I'll say 0.3 and negative 0.6. All right. The only other thing we didn't do is there's a little minimum at the bottom, but I already zoomed in on that, so I saved myself a little bit of work. Let's just do it again. Second, calculate. Minimum this time, number 3. I want to figure out what's at the bottom of that valley. I'm already on the left side of it. Just hit enter. Scroll to the right side of it. Hit enter. Hit enter again. Tells you the minimum's about, if I round to 1 decimal place, 0.7 and then negative 0.9. Okay. Questions finding mins and maxes in the calculator? Okay, we're not going to go through the whole next problem, but I do want to tell you this. If the calculator says minimum, and then it gives you this, let me just make up some numbers here. Actually, your calculator won't even say that. Calculator's going to say this. Have you guys seen those E's in the graphing calculator before? Okay, so they usually give you a very long string of decimals, and then at the very end it says E and then like a negative number. Okay, that means that, if you don't remember, times 10 to that power. That's how your graphing calculator gives scientific notation. So if I have like negative 9 times 10 to the negative 5th, that's a super tiny decimal, right? 0.0009, whatever. Okay, this is your graphing calculator's way of just kind of freaking out when it gets close to 0. If you see an E in your big long string of numbers, just say 0. It's a super tiny decimal. It rounds to 0. Okay, so this, both of those, I see the E in the X and the Y coordinate, so I would just say 0, 0 if I see that show up on my screen. All right, any questions? Mins and maxes in the calculator. It's all under that calculate menu. We're going to use that a lot. All right, let's finish out even and odd stuff now. That's the last part of this lesson. So I'm going to go back to that little bubble we had at the top. We know how to look at a graph and say whether it's even or odd. It's even if it's symmetric to the y-axis, it's odd if it's symmetric to the origin. We can also prove if it's even or odd. Now, we did proofs with symmetry to the y-axis and symmetry to the origin in the last chapter, but they were kind of clumsy. Remember, we had like the 3 columns and it was a lot of work. And it was 3 different things depending on what I was testing for. Now, because we're limited to just things that are functions, it's going to be easier. All we're going to do in both cases is f of negative x. We're going to plug negative x into the equation for x. If it simplifies to f of x, the original equation, my computer's sketching out on me here a little bit, that's a parentheses. If it simplifies to the original equation, it's even. If it simplifies to the original equation, but a negative in front of it, the opposite of the original equation, it's odd. Okay. Make sure you have those written down. And if it simplifies to neither, it's an either. Okay, so one test, one thing we plug in, and we simplify. We did stuff like this before. Remember, if we take it to an odd power, it's negative. If we take it to an even power, it's positive. All right, so let's finish those examples on the back. Show that x squared is an even function and x cubed is an odd function, both graphically and algebraically. All right, well, x squared, you guys know what that looks like. Looks like this. If you had to say why it was even, what would you say? What would your explanation be? Symmetry to y-axis. Okay, so that is the graphic proof. It's symmetric to the y-axis. If I want to do it algebraically, we plug negative x into the equation. So this is our original function, f of x equals x squared. All we're doing is taking the x out and putting negative x in its place. What is negative x squared? Just x squared. And isn't that the same as my original function that I started with? So f of negative x simplified to f of x. I plugged in negative x, I got out the original equation. Therefore, those three dots mean therefore, the little triangle, if you've never seen that before, it is an even function. That's all you have to do to prove it. Way shorter than the 3 columns we did before. Okay, x cubed is going to look like that, kind of like this squiggly little S shape. What kind of symmetry does it have? Yep, symmetric to the origin. So we know it's odd from its graph. Let's say we can't get the graph. We prove it algebraically. We start the same way. F of negative x. We plug negative x into our function. So negative x to the 3rd power. Make sure you put parentheses every time you plug that in. What's that going to simplify to? Positive or negative? It's going to be negative because it's an odd power, x to the 3rd. Is that the same as my original equation? No, it is not. Is it the original function with a negative in front of it? Yes, it is. Therefore, it is odd. Okay? Good. All right, let's do a couple together. Letter A. Determine if this function is even, odd, or neither. We're going to do one thing and one thing only. We're going to plug negative x into function g. Okay, so 3 times negative x to the 4th minus 5. What does it simplify to? 3x to the 4th minus 5. And what is that the same as? G of x. It's the same as what I started with, the original function. So I just proved that this function is what? What is it? Even. Plugged in negative x, simplified back to the original function. That's it. All right, letter B. Plug negative x in. G of negative x equals 3 times, make sure you're using those parentheses, negative x plus 7. What does it simplify to? Negative 3x plus 7. Is that the same as the original function? No. Is it the opposite of the original function? Is it the opposite of the original, of the whole original function, not just the first term? No, it is not. If it was the opposite of the original function, it would look like this, okay? And that negative might be distributed in. It would be the whole function with a negative in front, okay? So it is not equal to g of x, and it is not equal to the opposite of g of x. So therefore, this is a neither. This is what's going to happen when it's neither, even or odd. Okay, with your partner, somebody near you, try letters C, D, and try the graphing question at the bottom. See if you can finish the rest of the worksheet, and we'll come back together and check them. Okay?
Negative x to the third, and then x squared, that's or that's positive.
Answers. Your first answer is odd, and your second one is even.
What?
Okay, I knew you were going to get it wrong. That's okay. Common mistakes. Did everybody get it to simplify to look like this? Negative x squared over x squared plus 1. Did you get that far? Okay. When you have, I mentioned this yesterday, when you have a negative in a fraction, it can be in the numerator, it can be in the denominator, or it can be out front. It doesn't matter. They mean the same thing. If I say negative 2/3 like that, that's the same as negative 2 over 3, and that's the same as 2 over negative 3. It doesn't matter where I put that negative. And the same thing goes if there's variables in it, okay? So that negative in the numerator, I'm just going to choose to write it out front of my fraction instead. Do you see now that it's odd? Because it's the original function with a negative in front. Okay, so what we're doing really is like factoring the negative out of that numerator, just pulling it out front. Okay, now why is this guy even? Okay, and I heard a couple people say, well, there's all odd exponents, so it's got to be odd. That's not a thing. That's definitely not a thing. So here's why. I'm going to pull a negative 1 out of the top, so it looks like that, and I'm going to pull a negative 1 out of the bottom, so it looks like that. What's going to happen if I got a negative 1 out of the top and the bottom? They cancel. And if I cancel those, isn't that the same as what I started with? The fraction ones are tricky. If you're not sure after you simplify, which most of you guys I'm sure simplified it right, look at if you can take any negatives out, the numerator or the denominator or both. And that will make it maybe a little more obvious if it's even odd or neither. Yes?
How does that work with cross multiplying if you're just able to put the negative in there?
Cross multiplying, we only do if it's an equation and there's two fractions equal to each other. So if I had like, I don't know, negative 2 over 3 and 4/9, that negative I could use with a 2, or I could use it with the 3, and it's not going to change my answer when I cross multiply. I mean, those aren't equal, obviously I just made up numbers, but you get what I'm saying? And if you had a negative out front like this, you could choose if you want to pair it with the 2 or the 3, just not both. Because if I pair it with the 2 and the 3, the negatives would cancel and it would actually be a positive.
I guess you need to put-
Huh?
I guess you need to put-
Okay. Did you guys get the graph at the bottom? It's even, so you've got that mirror image over the y-axis. So it kind of sort of looks like that. All right. That's it for today. Just be careful with those fraction ones. All right, we're going to do the same thing as yesterday. I got 4 little exit ticket questions. We're going to check them at the warm-up tomorrow. You love the exit ticket. You do. I know you do. You guys all like collectively rolled your eyes at the same time. I saw it. It's fine. It's fine. It doesn't hurt my feelings at all. Okay. 1, 2, 3, 4, 5, 6, 7. We will check them together at the beginning of the period tomorrow, and then we will just wrap up this 5 lessons. All right.